In this problem, evaluate the limit as x approaches 2 of x squared plus 4x minus 12 over x squared minus 2x. For this problem, we're going to set up a table of values to see what the value of the function is as we get really close to 2. As x get really close to 2. So we're going to place the 2 right in the center. And once again, we're going to pick 3 values that are right above 2. And 3 values that are a little bit less than 2. Here we go, 1.9, 1.99, 1.999. And for the values that are right above 2 are a little bit bigger than 2, 2.001, 2.01, 2.1. So when we plug these values into our function, we get 4.157, 4.015, 4.001. Now, we can't plug 2 because we'll get an undefined solution. When I plug it in 2.001, we get 3.998, 3.95, 3.857. So from the table of values, I see that as x gets closer and closer to 2, the value of the function is getting closer and closer to 4. Closer, and 4. So we can say that the limit as x approaches 2 of this function is equal to 4. So for the way we've been able to calculate the limit is by seeing what value the function is approaching as x gets closer and closer to a particular number. Now, there's going to be certain instance when a limit does not exist. Here is our first example. We want to see what is the limit of this function as x approaches 2. X, y, well, if you look on the left side, when we get closer and closer to x equals 2, we could see that the value of the function is approaching 1. Now, if it approaches x equals 2 from the right side, and as we get really close to 2, the value of the function is getting closer and closer to 3. So the left side is getting closer to 1, and the right side is getting closer to 3. That means that the function is not approaching a single number as x gets closer to 2. So this is our first example of when a limit does not exist. If the left side of the limit and the right side of the limit do not approach the same number, then the limit of the function does not exist. Now, let's look at the limit as x approaches 0 of sine of 1 over x. And let's first look at the table of values. Let's look at x approaches 0 from the right side. So we are gonna have x equals 0.001, 0.01, and 0.1. If we evaluate the function at these 3 points, we get 0.827, negative 0.506, and negative 0.544. As you can see, these values are jumping around quite drastically. They're going from positive to negative, positive to negative. And as we get closer to zero, the value of the function is not getting closer to a particular number. Let's look at the graph of this function. About like this. Now, as we get closer and closer to zero, the graph starts jumping up and down between 1 and -1 quite drastically. This is refers to as an oscillating graph. The value of the function is not approaching a number as we get closer and closer to zero. So in this case, the limit does not exist. Anytime a function has this oscillating behavior, we can say that the limit does not exist. Now, let's look at a function 1 over square root of x. 1 over square root of x. And we want to know what is the limit as x approaches 0 of 1 over square root of x. Let's look at the graph. As x gets closer to 0, we can see that the function shoots straight up. This is an example of value of a function increasing without bound. In other words, the value of a function as it gets closer and closer to 0 cannot be concluded. Therefore, the limit does not exist. So there are 3 examples of when a limit does not exist. The first one is when the limit from the left and the right side of a function are not equal. So we say the limit does not exist. The second is when a function has oscillating behavior. And finally, if the limit increase or decrease without bound, meaning it doesn't approach a number, then we say the limit does not exist. And now next, find the limit as x approaches 2, find the limit as x approaches 1, and find the limit as x approaches 3 from this graph, The limit as x approaches 2 at this graph does not exist. The reason is because as x is closer and closer to 2 from the left side, the value of the function is approaching 3. But as x gets closer and closer to 2 from the right side, the value of the function is approach 2. Therefore, the left side and the right side are not approaching the same number. So the limit of the function does not exist. Next, let's find the limit as x approaches 1. Okay, in this case, the left side and the right side are approaching the same number, which is 4. Like this, Left side and right side is the same number. Therefore, the limit as x approaches 1 is equal to 4. Limit as x approaches 1 is 4, equal to 4. Finally, the limit as x approaches 3 does not exist. And the reason is that as x approaches 3, the value of the function is increasing without bound. Meaning that it is not approaching a particular number. Therefore, the limit as x approaches 3 does not exist. In this lesson, we learn about finding limits numerically using tables and finding limits graphically. Thanks. Thank you.